Alright, a few years ago I saw this video about an intersection with no stoplights. It's an autonomous intersection, which means there's no humans in control. Instead of stopping at the light, the cars just simply go through. No collisions, no stopping, all done by computers. This was amazing to me. The fact that slowing down cars and speeding up others could allow there to be no collisions was truly incredible. I thought that by 2020 this would revolutionize our traffic, but that's not the case. This concept isn't quite new. You can find tons of old videos from the 2000s showing old simulations of this working. However, I wanted to code this for myself. My school, like some others, has an annual hackathon where we get to code a project for 24 hours overnight. We weren't quite sure what to do this year, but once we stumbled over these old videos, we knew exactly what to do. Alright, so our first question was figuring out how are we going to do this? Some of the simulations that we saw had up to 4 lanes going each direction, so we decided to start a little bit easier. We had only 2 lanes going in each direction, which means that there were 8 lanes colliding in the very center. I worked with my 2 friends, Akash and Rahel, to build this project. We worked in Python since we knew it the most and it had a good GUI with Pygame. Pretty soon, the day arrived. So let's talk about how we actually decided to code this. Our first step was finding some pictures for the cars. We hopped online and found a pack of like 12 cars with a top-down view that we cropped and used for each image. The cars had a slight variation between them, some being trucks and some being minivans, and the sizes varied within that. With these images, we imported them into Pygame and made them each sprites. From here, we can give them a position, a velocity, and an acceleration to have them move across the lanes. At this point, we hadn't figured out any of the intersection stuff yet. We just wanted to show that the cars could go through the intersection. By the middle of the first day, we were able to have cars spawning on each side of the screen and going up and down. Of course, the intersection didn't work yet, but the important part was we were able to get cars to interact and spawn. Then, we decided to jump more into theory and figure out how are we actually going to get these cars to slow down or speed up depending on where they are. Basically, it comes down to a few cases. First of all, cars traveling in parallel lanes next to each other will never hit each other. For our purposes, we didn't have any merging or any sort of weird traffic issue where the cars wouldn't go in a straight line. Then, there are a few more cases. First, there are cars going in the same lane, and the car behind is going to accelerate into the first car. If this is the case, we have the car in the back slow down. This is applicable for any of the 2 lanes in any direction the cars are going. The other case is the T-bone case, where 2 cars are going perpendicular and are going to run into each other. Here, it's a little bit more complicated in terms of the math, but we can still figure it out. Essentially, we want to speed up the car closer to the intersection, because that's the one that's going to be hit. By doing this, we can allow that car to escape the collision before it even happens, and let the other one pass behind slowly. We experimented with a different mixture of speeding up and slowing down, and we were able to find the right combination. Essentially, we want to have it be 50-50, with the first car speeding up a little bit and the other one slowing down a little bit as well. The hardest part was combining these 2 cases, the horizontal collisions case and the T-bone collisions case, together. For example, if a car needs to slow down because it's going to T-bone, but also speed up because it's going to be hit from behind, we need to figure out what to do in that case. In terms of physics, we had a pretty intricate system. We managed the velocities, the positions, and the accelerations of all the cars. And the coolest part is, we made this close to real life. We only changed the accelerations of the cars, not the positions or velocities, which is impossible in real life. By just doing this, we essentially pushed more on the gas or pushed more on the brake, depending on what we were doing. So, theoretically, our simulation could run in real life if we outfitted the car with our software. Since, of course, we're in a hackathon, all of our code is going to be open source. I'll put a link to it in the description if you want to check it out yourself. Basically, we have 2 Python classes, one for the cars and one for the Pygame window. Pygame window spawns in a bunch of cars, and the algorithm within that window solves all the equations so that the cars will not hit each other. Of course, by the end, our system wasn't perfect. We still had about 20% collision rate with all the cars, which of course could never be transmitted into real life. The hardest part was obviously managing our time. Since we only had around 24 hours to code, and we also had to sleep some time in that interval, it was definitely hard to get all the code done in that short amount of time and plan out all of our simulation. In the end, it was a fun experience, and I think the result that we were able to make in 24 hours is pretty crazy. So go ahead and check out the link in the description, which is the GitHub repo for all of our code. Thanks for watching. Goodbye.